Dear boys, you're most welcome to our online class. We just pray and hope for your safe life at this condition. Your safety, your security is the first priority for us. That's why we are all staying at home and trying to deliver some online classes, online lectures for you so that you can make better preparation just staying at your home. And your cooperation will make this effort successful, and we can hope that we will get a better result whenever you just cooperate with us. So we were just trying to review our chapters, and we were just continuing with chapter 5, state of matter and pressure. In my last lecture we had some discussion on different topics of this chapter, and as this is a review class, we have no need to have detailed discussion on different topics. So we have just focused on some topics that are important for your creative type questions, and on today's class we will try to solve a creative type question. This is a board question of Rajshahi board. Let's have a look on our stain. This is a diagram based question, and on our last class we had discussed about Pascal's law, and this question is related to Pascal's law. Let's have a look on the diagram. Here are two cylinders and two pistons are connected here. If we apply F1 force on first cylinder, then the second cylinder will feel the force F2. The value of F1 is given here on our stain, that is 500 Newton, and the cross-sectional area of the first piston or small piston is 0.09 meter square, and the cross-sectional area of second piston is 2.7 meters square. And as amount of force 500 Newton is applied on first piston, so it just displaces by an amount of 5 centimeter. That is also given in our stain, and whatever we have to determine now, just have a look on the questions. This was our stain, where the cross-sectional area of two pistons are given, the force applied on first piston is given, and the displacement of first piston is also given. So what are the questions according to this diagram? First one is, what is called atmospheric pressure? Second question is, explain why utensils float on water. And third question is, find out the value of F2. And the final question number D, is there any change of work done in both the pistons according to the given informations of the stain? So these are the questions for us. First one, knowledge based question, is what is called atmospheric pressure? The pressure exerted vertically by the weight of the atmosphere. When we just try to say the atmospheric pressure of a specific area, then this pressure is just vertically exerted vertically by the weight of the atmosphere on per unit area of earth is called atmospheric pressure. As we know, the equation for pressure is equals force divided by area. That means per unit area, the force exerted on force or weight exerted on per unit area is called pressure. So using that equation, using that concept, we can just define the atmospheric pressure here. Our second question is, explain why utensils float on water. In this question will be discussed with two different logic. First of all, Utensils, all of us know that utensils are made of aluminium and float on water. uh, though the density of aluminium is greater than the density of water, so comparing their density, aluminium can just emerge on water, but aluminium used in utensils are too thin. That means only a thin layer of aluminium is used here, and the surface area is greater, hence the volume is also larger. So though we are using aluminium, but the layer is so thin and the surface area covered by the aluminium is so greater, hence the volume of that utensil gets larger. And this is the first point. And another point is just from our law of Archimedes law. From Archimedes law we have known that whenever the weight of the displaced water is larger than the weight of the object, then on that case the object just floats on water. What is the condition here? Here the condition is the weight of displaced water will be larger than the weight of that object. So in case of utensils, the inner parts of utensils are hollow, so weight of the water displaced by utensils is larger than the weight of the utensils. So from Archimedes law we can just say that the utensils will float on water. So by using these conditions, by using these laws, or by using this logic, we can say that utensils float on water. First of all, utensils are made of thin layer of aluminium, and their surrounding area is, or volume is so larger. And second point is the inner side of utensils are hollow, that's why the displaced water area, that means the weight of displaced water by utensils is larger than its own weight. That's why utensils float on water. So this is the answer of our second question. And our third question was what is the force on second piston? That means what is the value of F2? At first, before doing this math, this calculation, most of the time we just try to say on class that at first you have to note down all information given on your stain, including their values. So from our stain we just get that area of small piston is 0.09 meters square, and the force that is applying on small piston is 500 newton. Area of big piston is 2.7 meters square, and the displacement of first piston or small piston, if we denote it by L1, then L1 is 5 centimeter or 0.05 meter. These are the overall informations from our stain. Now just let's start our math. As we are told to determine the value of F2, that means force on second piston. Here we can apply the Pascal's law. According to Pascal's law, we all know that whenever a force is applied on a confined area, that force X just transmits equally on that area and just works perpendicularly. So here whenever a small amount of force is applied on first piston F1, so this force will transmit in all direction of these confined area, and it will exert it on vertically, and then it will just make a displacement on piston 2, or it will make a displacement on the big piston. So applying Pascal's law, we just can figure out a equation we have just noted this equation in our earlier classes, that is f1 divided by a1 is equals f2 divided by a2. Then from this equation we can just determine the value of f2, because the value of f1, a1, a2 also are given on our stain, and using these values we just get the value of force on large piston is 15 into 10 cube Newton. Whenever you are trying to solve or you are trying to observe this type of lecture, that means lectures related to creative type questions, hope that you will have necessary preparation with you. That means you will have to carry your notebooks or writing element with you, so that you can note down the math and you can do the calculation as well. So let's just proceed on our last question. What was our last question? Our last question was, will the work done be same for the both piston or not? We have to explain this one with our mathematical calculation. So for calculating the work done, we just know that work done equals force into displacement. That means W equals FL. That means we have to know the value of F and L at first. So for first piston, if work done is W1, for that the equation will be F1 L1, where the value of F1 is given in our question, but the value of L1 is not. L1 is also given, that is 5 centimeter, and if we convert into meter, that will be 0.05 meter. So work done for first piston will be F1 L1, and by applying the values here we will get the total work done will be 25 Newton meter here according to our equation. So this is quite easier to measure the value of work done by the first piston, but in terms of second piston or large piston, the work done will be W2 equals F2L2, where the value of F2 we have determined this one on our question number C. From C we just get the value of F2 is 15 into 10 cube Newton, but the value of L2 is not given in our stain, so we have to determine it first before calculating the work done. So how can we determine it? As from the stain we just can observe that there is a displacement of 5 centimeter due to the force of 500 Newton. So as this is a confined area and the force is applied on a liquid, so there is no chance of compression here, because applying force we cannot compress liquid. So the volume of displaced liquid in small cylinder due to the force of F1 will be just equal to the volume of lifted fluid in large cylinder, because there is no compression of liquid. That's why if we just apply a force on first cylinder, and that will lift the first piston, and this force will lift the second piston as well, because the fluid is confined on this small area. So applying this logic here, we can say that A1 L1 equals A2 L2, where A1 L1 is the volume of displaced fluid in small cylinder, and A2 L2 is the volume of lifted fluid in large cylinder. So from this equation we just can after a small calculation we just can determine the value of L2, and that will be 1.666 into 10 inverse 3 meter, because we have the values of A1 L1 and A2. By applying these values we just get the displacement for second piston or large piston is 1.66 into 10 inverse 3 meter. So now we have got we have gotten the value of displacement L2. Now there is no problem of determining the work done by large piston. So work done by the fluid on large piston will be W2 equals F2 L2, and by applying the values of F2 and L2 we just get the value of work done. W2 is equals 24.99, that is almost equal to 25. So observing the both results of W1 and W2, we just can sum up that the work done on both pistons will be same. And this was our question, that there is whether the work done will be same for both pistons or not. So from our calculation, from our logic, from our explanation, we just can say that work done for both piston will be same. So this was an example of related to Pascal's law. There are some other topics in this chapter, and on my next class I will try to focus on some other creative type question related to some other topics. So you just try to practice the maths, and try to practice the creative type question on your home. And as you will have to attend in-house model test for all subjects, so try to practice more and more and review the chapters as early as possible. So boys, that is for that was our today's class related to creative question, and that's all for now. And have a good day, have a good time. Wishing you very best of luck. Okay, goodbye.